Hello and welcome to this lecture on extending interfaces. Now, like classes, an interface can also extend another interface. But unlike a class, an interface can extend multiple classes too. At the end of this video, you should be able to understand the rules involved in inheritance amongst the interfaces, describe the conflicts between the members of interfaces during inheritance, use nested class in an interface, and understand the diamond problem involved in interfaces inheritances. Now, let's begin with what is inheritance among interfaces. The concept of inheritance can be applied on the interfaces just like the classes. However, unlike a class, an interface can extend more than one interface. That's like multiple inheritance. So if somebody says multiple inheritance is not allowed in Java, they are probably wrong, because multiple inheritance is allowed in terms of interfaces. But they may be right also, because inheritance is about code reusability, and you literally don't have much of a code to reuse or be benefited out of. So inheritance is possible with interfaces too. However, they are not really code reusabilities. Now, an interface cannot extend a class, or a class cannot extend an interface. They are incompatible types. Now, take a look at this picture. Data source is an interface in java.sql package that inherits from wrapper as well as common data source. As you can see, each of them have many methods to inherit from. And a data source is an interface that is going to be implemented by some classes. For example, in order to provide a connection pool, MySQL may provide a connection pool, and that is implementing data source interface. So when MySQL connection pool implements this data source, MySQL connection pool has to provide method definitions for each of these. That becomes the contract. When a class implements an interface which has inherited from more than one interface, there are a lot of complexities involved. Number one, the class must provide or override all abstract methods for each of those interfaces. Now, number two, if two interfaces have defined a common method, then implementing class must implement that method only one time. Now, all this bookkeeping you'll have to do if you're having multiple inheritance. Let's take a picture and understand the same. There is an interface A, there is an interface B, which defines collectively four methods: F1, F2 in A, F2, F3 in B. But if you see, as a union of the functions, there are only three of them: F1, F2, F3. Now, both of them are inherited to C. That means F1, F2, F3 is inherited to C, but C also declares F3 and F4. Now you can see the union of all these is only four methods: F1, F2, F3, F4. Now, when a class D implements the interface C, now that needs to take care of certain things. Number one, the methods F2 coming from A and B, that has to be implemented only once. Similarly, the methods coming from C and B, that is F3, that has to be implemented only once. Now, this has to be taken care by the implementer of class D. Now, there are some conflicts that may arise. For example, if you have two method signatures but with different return types in two different interfaces, when you inherit, now that becomes a problem. So if an interface attempts to inherit from these two, the compiler would tell you that there is something wrong. For example, imagine there is an interface A and an interface B, and both of them define some function, one of them with a void return type, another one with a string return type. Now, independently, these two have no problem, because there is no association between A and B. You can create an object of some class implementing A, object of some class implementing B. But however, if you write an interface C extending A and B, now compiler will now tell you an error, because now C inherits these two method signatures and the signature is same, return type is different. That is not acceptable. So the compiler would result in an error types B and A are incompatible, both define some function but with unrelated return types. Now that is something that you have to take care of. And in a long run, this will become a huge problem, so either be careful or avoid this. Like a class having a nested classes, an interface can also have a nested class. Now these are called inner classes, like in classes. Now here is an example. Interface A defines a class B. Now class B is going to be a data type. Obviously, if you try to compile this interface now, the resultant dot class will be $a$b.class. So it is a perfectly valid class, and objects of class B can be created somewhere. Now imagine the class B has a hello function which is marked as static, but not necessarily that it has to be marked as static. You can have a non-static method too, but just for the example's sake, I have taken this method as static. Methods in the implementing classes can now make use of these inherited nested classes. Now, as an example, class C implements A and has a function called void sayHello. Note that sayHello internally calls b.hello. Now, this is only possible because C implements the interface A. So, all the members of class the interface A are members of class C itself. So it is as if the class B is a nested class of the class C itself. So it is like own member. So there is no problem in calling that. Now somewhere else, when we say C1 equals to new C and say C1.sayHello, sayHello will call the sayHello function. Now sayHello will internally call b.hello. Of course, if you remember, hello is a static function in the B class, so we are able to call that. Otherwise, you can still say b1 equals to new B and say b1.hello. So that is perfectly alright. Which means any class that implements interface A can be benefited out of these particular nested classes. Now, there is a very popular problem that you come across, something called as a diamond problem, or the diamond or the deadly diamond death. That's a problem name. Now, what is this problem? Let's understand with a picture. Now, as you can see, with multiple inheritance possible with interfaces, now here A, B, C, D are laid out such a fashion that it looks like a diamond. So, B and C are subtypes of A. They both inherit do something signature. And the interface D now has that inherited member too. So, if B, the interface B has a nested class called NC, and now NC just as a short form for nested class. Now, if you have this and you want to create an object of D interface, so we can do something like this. Now, there is a class test implements D, that means that it is inheriting that NC, and if you say nc.fn, it's just going to call this function. No problem, because there is only one copy of fn and that is available in the class, the interface B. So, now what if the D now tries to rewrite the inherited member? So NC is now overriding the one that is coming from the B interface. Because of this, the B.NC is now hidden. Now, whenever you say, so the class test implements D and you want to call nc.fn, it's going to pick that from D because that is the overriding one. And because of that, there is no issues, so you get the output. However, imagine instead of in D, in the interface C, we put this one. What happens now? Now note that D being a subtype of B and C inherits both of them, and then now there is a conflict because the names are same. NC from B, NC from C. Now if you call this, which one to pick becomes confusing. Now this problem is at the runtime you will get, and the runtime error you will get that as reference to NC is ambiguous. Both class B.NC in B and class C.NC in C, they are ambiguous. So this is a real problem that you get. Now let's quickly summarize what we have seen so far. An interface can extend 0 or more other interfaces. The implementing class must provide method bodies for all the methods from all interfaces put together. Now if an interface has duplicate methods, you have to implement only one time. An interface can declare a nested class that can be used by all the members of an implementing class.